Stop. Okay, we're live, and thank you for stopping by. What we'll be doing today is we will spend the next 1 hour. Well, I will spend the next 1 hour writing a LSP server. If you've followed the last episode, what we're going to do is basically write an LSP for GraphQL. Now, you may say, why don't you just use something like Graphical or Insomnia, where you've got all these live server stuff and IDE stuff all built in. The problem is, I don't particularly like any of those. Like Graphical, it's a memory hog, right? Yeah, so I want something that works in Emacs straight up, works with eglot, and does not have Node.js. It's as simple as that, right? So yeah, that's what I want to do. Is I want to build a GraphQL LSP server, and I do this mainly because I use GraphQL's at work quite a lot. So last time around I didn't realize that there was a chat, so there is a chat now. Hi Sangam, nice to see you. All right, so let's switch on back to coding, where I will explain how I built this GraphQL server. Now, the key thing I want to point out is from last time around, I only compiled the program once at the end, and I think that would be a very nice, fun challenge to do. Is to say I want to spend my time coding, and then I'll compile it right at the end. I'll spend only exactly 1 hour. I've got a timer, yeah. Let's see. Move that. And let me set my timer to 1 hour, and we should be good to go. So 1 hour. Right. So since the last episode, not much has changed. I have not actually done anything. The only thing, well, let's take that back a bit. I've not done much. Okay. So the only thing that has changed since last time is I've moved the definitions into a package called LSP. Gave all the data types some comments. Well, some data types have comments. Some don't, right? So for example, client capabilities, we're not going to bother working with different client capabilities. So I'm not going to do much on this. But the point is, where I left off the last time, I compiled the program and it ran. So let's make sure that my refactoring has not changed anything. So go run start.go. Okay, it's running. The server is running. This is the main. And you know, it's not going to do much. It's not going to show you much. So today we're going to go a bit more and build more features into the server. Then we can probably test it with a proper LSP clients like eglot. So in case you don't remember what's happening, I created something called a server type, and the server is basically a JSON RPC2 handler, and we use the source graph JSON RPC2 package for this. Yeah, so we created a thing called with an initialize method where it initializes the server. So it gets it receives a message saying initialize, and then you automatically initialize. Initialization must only be done once, so there is a protector here. So we should check here, for example, if then do nothing, right? We return nil. Okay. Let's see. Right. So if I scroll down here, nil. Okay. We'll just return nil for now. And do I have the error stuff here? Or in the LSP package? Okay, so I do have the errors stuff here. List error, for example, it's a list of errors. So we might as well create a new error type. So a no op error basically is something that has no op. Causes it's the kind of error that you can ignore, but it's not necessarily good to ignore. At the same time, it's okay to ignore because nothing has been done, right? So when nothing has been done, well, you can't do much about it, more or less. So let's create make this an error. Uh, so this is both an error as well as a message, right? So if we go back to this, we can return no op error and says, okay, if it's initialized, we are going to return an error that says no operation happened, and it is really up to the handler to manage this. Okay, so there we have it. Now what we want to do today is figure out what happens when you open a file. When you open a file, you want to read the file and put the file into a text, into a data structure or something, right? You want to possibly parse the file. Yeah, so that's the easy part, right? So let's see. What do we need? When we open a file, the client, in this case, in my head, I have eglot in my head. And eglot is sending a message to this server saying, text document did open, and it has some parameters, right? I did read ahead on the LSPs, so let's do some coding instead of, like last time around where I basically just digged around and read the manual. So yeah, let's not do that this time because it's boring. So if the request has no parameters, well, then we know we need to say something's wrong, right? Okay. Now, the did open parameters, right? I've okay. Let me just we'll just use this as EWW again, I guess. GraphQL, what the one LSP specification. All right, GitHub pages. Da da da. Okay, so this is the parameters for the did open thing. We're done with this, so go back to LSP. Now let's create a new data type here. What's it called? Did open. All right, so what is this? It's a text document item. So let's find out what text document item is. Ah. All right, so the types are a bit irritating because these are TypeScript types and they're all like fancy interfaces and stuff like that. And it really doesn't gel well with like Golang types. and you kind of have to mirror the data structures. If you have this, you have a thing called a type here called text document item, which is a struct. Okay, this is a struct. So see, I'm trying. URI is a string. The JSON would be URI. Yep, I think that's correct. Language ID. String. Aha. I had two L's there. I might be well. Text. That's the one I'm looking for. String. It's on text. So text document item is and this for myself contents of the file. The rest are all additional stuff that metadata that the LSP sends. Okay, so now we're back here. All right, so we are back here, and we're going to say what are we going to do when we open a file, right? So we check if the parameters is nil. If the parameters is nil, then oops, we can't proceed. We'll have to do something else, and now we'll have to unmarshal. So params equals lsp dot text. Was it called? Did open? When my LSP is not working. There you go. I guess this looks great. That's right. Yep. And params. Hello, Egon. I'm just hacking around Egon, just FYI. There's no fancy things. Although I think there will be a use case for ropes. There's a package that I wrote. That basically allows you to build ropes in Go, and the reason why I wrote skip rope, the package skip rope, github.com/qxy/skip rope, is because, well, I at one point I actually built my own text editor, and so yeah, skip rope. Okay, now I have unmarshaled my JSON parameters, and now what do I do? So I have the URI. I can open file based on the URI from the parameters. So Jesus, what the hell is this? Okay, eglot failed. There you go. That's more like it. That's the, so we can open a file here. I guess you want os.open. Yeah. Oh, hang on. So the URI is something like this, right? And then path to file. So should we open this? We'll probably have to parse this thing. Oh, hang on. We don't need to do that because we actually have the text itself, so we can do something about the text, right? But you know what? I think this server needs a cache map of sorts. So string to metadata, I guess. We'll call it metadata for now. Basically, what I'm thinking of is basically that file, you know, the text, the URI, language tags, probably where the server lives. Okay, you know what? Let's just build this. So what we have it is a file metadata. Call it file metadata. And we have the URI. Oh, we don't need this. We just put LSP dot text document item. So that's where all the unmodified stuff happens. We'll probably also want the schema. Yep. URI. So this allows you to have each individual file will have its own mapping to a particular schema location. Yeah, that sounds interesting. We can do that. And we'll call this aha. Now we can't just like create a new server. So new server. So this map essentially acts as a cache of sorts, right? So when we have a new file, we put it into the map, and then we take it out. When we want to edit the file, it's going to be indexed by the URI. And it will contain the actual text, the documents of the file itself, which we will parse with the vector slash GQL parser bit, which I have talked about the last time around, just not yet. So so what we do is we take the params dot. Oh, okay. So there's a text document. There's the language ID. Language ID. Okay. Dot text document. And I'm missing something, am I not? I'm missing something. Still missing something. There you go. Right, so M is a metadata, and we're going to put this dot M dot URI equals to M. Now we've basically opened the file. And I think that's all we need to do when we open a file. We don't need to parse it right now. We might want to parse it. So here I'll put things for additional stuff. So by default, then there will be no schema URI with related to this file metadata. Right, so by default, it will just be a file that that sits somewhere. Which reminds me, we should also probably have a sort of global for the server. Oh, there you go. We do have a server endpoint. This is a global. This is exported for a good reason. So I like a package for options called ops. I'll probably show you in a future episode or something, but yeah, I don't like, I'm not a fan of like Cobra or Viper or any of those CLI tools. I'm a fan of using ops, and it makes it very, very simple. Um so I'm not too worried about those things. I can actually do them at the end, as opposed to having to think about your apps and your programs upfront, or sub commands upfront. You can just build using ops. And you know what? Let me just show you the website. jpilora/ops. So Jamie Pilora is a guy in Sydney, and yes, I live in Sydney too. So he wrote a package called Ops. Go check it out. It's actually very cool, very useful. Yeah. So to do processing stuff. Okay, so in the processing stuff, what we're going to do is basically parse the document. Yeah, and one of the tricks that you have to do to parse is you have to check for the word keyword type. I've been thinking a lot about this clearly, so I'm sort of jumping ahead on myself. There's nothing to return, I believe. Yeah, so there's nothing to return. We just return nil. Huh. Yep. And that's it. Now let's say it did save. What do we want to do when the file saves? We need to update the file, the text of the file, and that requires a snake, a rope of something. So this is what happens when you open a file. It sends a message. Your LSP client sends a message to the server, just telling what the URI is and what the text content is. So a good idea would be to, okay, let's just do the parsing stuff, temporary parsing stuff. Parse a string into, so let's go to go.pkg.co.dev/github.com/vector/GQL parser/parser, I think. Yeah. So this is the parser. It has two things. It has parse query or parse schema. What is a source? Okay. That's very interesting. Types. Okay, 1 second. I gotta check this out on my normal browser. ast.source. Is that yeah? What is source? Ah, right. It is ast.source. Okay. So this source is actually the ast.source. This is ridiculous. I mean, dot imports suck. So Let's figure out what ast.source is. Okay. Move the chat away. Okay. Name. Build, name of the file. Content of the file. And that's it. So, pass a string. When you pass a string, give it a name as well. File name. URI. And we'll just ast dot. Okay. I'm going to return an interface for now because you have to pass either a schema or a query. So when I mentioned that there was a trick, well, this is it. You first look at the string to find if it contains a particular regular expression, and then if it contains that regular expression, you pass it as a schema. Otherwise, you pass it as a query. And the thing is, in GraphQL, that it is, you've got two different types. You've got a schema, which is one language on its own, and you've got the query, which is another language. The queries, the mutations, they're a different language. Now, on the website, it says that they're the same language, but the way it's designed is actually two separate languages. So you need to figure out what to parse as. So if you take a query and you parse it as a schema, it will not work. Or if you take a schema and then you parse it as a query, it will also not work. There are components that are similar, the curly braces, the blah blah blah, but by and large, it should not work, right? So the trick to figure out whether something is a schema or a query is to look for the word type, type. And because we are lazy buggers and we don't want to actually lex and relax this thing, so yeah, we're just gonna look for a regular expression. And the best part is I am not like, I don't have regular expressions at the top of my head, right? So let's just write this then. Must compile. Excellent. Yep. Type. There you go. We're just gonna look for this string. To find out if it's a schema. Now, if you're good with regular expressions, you should not ever use this. I'm very lazy, so that's what I'm doing. You can obviously build a better regular expression than this, but for this, I think we're not going to do that. All right, so what we're going to do is we're going to find the fastest one. I don't remember which is it. Find string index. No, okay, find string, I guess. A. And what does this return? This returns... Nope. Find all. String. A, -1. And this is wrong. Okay, I have no idea what's wrong with this, but I suspect that this regular expression is wrong. Or maybe not. I don't know. All right, so okay, we might as well return no. So in this metadata, we'll also have a schema. Ooh. So if it's a schema, you just go, you know what, it's a schema. So let's see, you've got load query. Hang on, that's interesting. Sorry, I'm actually reading the vector slash GraphQL. Okay, there you go. Parser dot parse query. Yep. I swear. Yeah, this is the one. And source is name URI input a built-in is false, I guess. Yeah. Okay, so we can pass a built-in source, so that should be part of the initialized thing as well, I suppose. We'll come back to that later. So pass query, it will either query error. So I'll also need to return an error. If that's the case, then I'll just return what is unlisted? Listed. Oh, the YouTube video is unlisted. I think that means something. Not helpful. I will work it around at Daryl. All right, does this implement an error? Does GQL error implement an error? Well, that's annoying. Oh, it does implement an error. Good. Okay, so this is what happens. You can do this. Okay, so okay, so in this case, we're returning the error back to the server. So you know, I don't need this right now because there's no need for it. I can just do a type switch on parsed, which would return either right. Now, eventually what I'll do is I'll wrap this up nicely. I'll probably replace these types with another type and then put them in a nice interface so we don't actually have this. Really, the only reason why I'm doing this is because I'm not that, yeah, I don't know what's the one thing that they have in common, what interfaces these types implement. So I will check it out later. Why not? So, okay, so we've managed to open a file and we've managed to parse the file. That seems simple enough. And think about it. Our goal is, of course, to finish up with a hover and completion. So if it's a schema, right? If we parse the file and it's a schema, then we will want to say that the schema URI is also the URI of the file itself. So the file's own schema URI is itself. Yeah. The rest of the files can have this can be configured from the rest of the file, I think. You can use something called code actions to set a particular schema URI for a particular file. I think that is what we can do. All right. Okay, I did not expect to finish so fast. I expected to finish this to take a whole hour. And it would seem that I have 25 more minutes remaining. Yeah. This is a 1 hour a week programming challenge that I'm doing. I don't want to compile till the end of it. So yeah, right now I have this. I do not know what I want to do with it. Right. What happens when you save a file? Nothing really, is there? Okay, so let's go through the mental exercise. You're writing a schema file. You hit save. You open a schema file. You hit save. Okay. You actually need you need something here. So let's go back to the specification. Okay, not this one, right? Nope. Okay, so text document did save. That's the params that we need. So LSP/LSP. Again, this is just ridiculous. I am writing the struct like that to mirror the struct, the data structure given in the specification. Coding to a specification can be nice, sometimes it can be terrible, especially when the specification is not that great. So anyway, in this case, the specification is okay. I just want you to know. Okay. But this specification is written with TypeScript in mind, so translating TypeScript to Go is fairly straightforward, but it's not ideal, really. Depends on the include text value when the save notification. Okay, sure, why not? Okay, now let's see what the text document identifier is. It's just the URI. Why couldn't you just give me the URI? Fine. So if you're writing this in pure Go by itself without having to bother with this structuring, marshalling and unmarshalling of JSON, you would probably just, put a string here as opposed to this. But we're following someone else's specs, so let's be respectful of that, and yeah. So when you have this did save, so you have to say if request dot params is equals to nil, and then you follow the rest of it. Params speed dot did save. Aha, my own LSP is not working that well, so why not? This entire bit can be optimized, can be abstracted out in some nicer languages, but I'm happy with this. I've got no complaints. Really? This obviously can be cleaned up, but not with a lot of abstractions. One of the nice things is that abstractions in Go really mean abstractions, right? functionally abstract something off. Yeah, I've got a lot of thoughts about that, but I'm not going to talk about them now. I'm just going to drink some water. All right. Now what? I've got a file. Now I can look in the file and say, okay, so is there a marker for this? There's no marker. So we check if the text is nil, if the text is empty. If the text is not empty, then we replace the text inside the current cache. That sounds work. That could work. So id is equals to params. Yep. id. Wait, hang on. If it's empty, right? If params dot text equals nil, then we replace it wholesale. Yep. id. What's this? Text document. Hello. Eglot's not working. This is the beauty of LSPs, right? I mean, a long time ago, I just used Go mode and it just works out of the box. Now you've got LSPs, you basically have to reconnect to the server all the damn time. And the hovers don't necessarily, the completions don't necessarily work, and that is very annoying. Okay, so let's just go back to text documents, item dot text. Ta-da! Finish. That's it. And M is obviously s.m. Why not? Did save, did change. When something's changed, you want to update. Basically, it's the same thing as save. Alright, so this is the pretty boring stuff. I guess we can hammer it out now. Maybe I should have just, generated this, but actual content changes. Content changes describe a single state change to documents. If there are two content state S, then C1. So it's a list of changes. Okay, this looks more interesting than I expected. So might actually get to use ropes. Yeah, I sounded very evil with that. Version text document identifier. Oh my god. And you want to bet it's just a URI with a string? Yeah. With a version number? Yeah. So to anyone new to anyone who's watching this and just arrived, the challenge is that I'm not going to compile till the end of the session. I have a 1 hour session. I'm not going to compile, and basically, if I'm good enough of a programmer by the end of the night when I compile, I'll have one or two mistakes, and that's it. There won't be much issues. There will not be much issues, and I think that's part of the challenge that I'm particularly interested in. Which is to say, you can get all the help you get with LSPs and all that, but the idea is, at the end of it, you're going to compile once, run it once, and it should work. So let's find this. There you go. Yay! It's ridiculous. Oh, a number or null, so we'll do this. Ha! Oh my god, the names are very long. Okay. Range is a range, yes, very helpful. Can be null. Range length int. Okay. Now what's a range? This is one of those yuck shaving things. You shave and then You keep shaming. So right. And what is position? Well, right, so let's, okay. Line number, character number. Line int JSON line. Okay. That's it, I think. Arranges the start and end position. Okay, so these are pretty standard stuff, right? In any text editor, you'll have any of this. So I'm not like begrudging on this. And in fact, having them as JSON marshallable types are very, very useful. And I think I'm going to start doing that. It's very useful in future. Yeah. Position P, capital P. There you go. Yeah. Okay, I'm very tempted to just build and see what I need to do, but oh yeah. All right, so here's my to-do marker, and the reason why I'm doing this to-do marker is because I think when we open the file, or save the file, we need to put the file contents into a rope. That way, when we make changes, it's going to be easier for us to make changes. Otherwise, we're going to have to search for line. Take the text file, search for the line, go to the character, replace the characters in the range, and that's going to be a pain in the ass. Text diffing algorithms is not fun, I would say. Yeah. So you know what? I'm going to change this. Call it a file. Yeah. We'll call it a file for now. And we will. Okay, so this is a file. And here, instead of there you go. We'll do this for now. This way I can take the file off and pass it off into a different function that does all this cleanup work, so to speak. Yep, I can do that. Why is this v2 and why is this not v2? This is going to kill me one day. Is this correct? Is the parser v2? I will check. Most likely not the case. Oh wow, all the errors are gone. Huh. Okay. So what am I going to do next? Schema URI, rope, and skip. Do I have skip rope? And that's 1 hour. Okay. I'm just gonna go get this. Yeah. Version 1. That's all good. Nope. I don't have skip rope. Okay. I don't remember any of the types. Type is a rope, obviously. And that's it, I think. Insert at. That's the aha. So one of the things about skip rope is this. How do I keep track of row call information? Thing is, skip rope does not have any line or column information. You actually have to manually do it yourself. And I wrote here, I do not think it's wise to edit to the core data structure. I think this is coming back to bite me in the ass. So I wrote skip rope many years ago. I don't remember how long it is, but so I don't actually remember much of the docs. I mean, I of the API. I know I wrote a type that is a pretty fast. In fact, it's the fastest at that point in time. It's actually the fastest rope data structure based on a skip list. In fact, it's the fastest rope data structure period at that point in time. So yeah. I don't remember how to use it. Okay, more or less I do remember how to use it, but I don't. You know what? You're the worst. You as a software developer, in the past, you're the worst developer, and your present self, your future self will curse your past self. That's the case. So yeah. Right, insert. Okay. All right, the hour is up, so I'm going to all right, yeah, text document item. I'm going to finish this and try to run it. So the reason why I did new file, is because skip rope, the rope data structure requires an initialization, and you don't want to mess that up. So you just want to have one location where you do all the initialization, and then everything else follows after. Okay. Right. So let's try to run this for once. Undefined skip rope. Eglot. So this is not counted. See, eglot failed. LSP suck. What? Okay, it's running. It works. 2 compiles at the end of it, and no errors. Okay, that's pretty nice. Obviously, we'll have to write tests for that. I'll probably do that offline because it's not very interesting. In fact, none of these seem terribly interesting. I think the most interesting bit would be the hover and the completion bits, which I'll do the next time around. Thank you for watching. Hope you learned something new. I learned something new. Yeah. Thanks for watching. It's been fun. Bye.